Yeah, hi everyone. My name is Asif, and I would be, conducting this session of. There would be two parts of this webinar. One would be of performance tuning, and one would be the next section would be of performance testing, which Nabil would be covering up. Uh, okay, so now from the performance testing, I'll make Nabil presenter.
Thank you, Asif, for handing over to me. So before I proceed further, the ending note, Asif has said, uh, everyone wants to come onto your website if it's smooth and if it's good to be go through, and they can smoothly have a checkout process without no hindrance in this complete overflow. But one of the reasons why performance testing is required, so this is one of the stats from 2000, February 6, 2000, where over 1 billion transactions were concurrently registered on the im- important portal around the e-commerce industry like Yahoo, eBay, Buy.com, Amazon, eTrade, etc. So with these 1 billion transactions, you need to actually identify the importance of performance testing, because if your application is able to have these huge number of transactions concurrently, then it's good to go. You have benchmarked it correctly, but you need to identify the leeway in it between. One of the major problems of in performance testing, you need to identify the need of performance testing when you have to reduce the development cycles. More scalable and more quality code needs to be registered for that. And then it's having a good performance is more about the credibility of any organization and their product. If you are not having a good performance on your website or on your portal, you are definitely going to lose a lot of revenue, and more than that, your credibility will be lost. And there is in today's age, there is no looking back once you have lost your credibility. Important part of performance testing is not about the expectations it's not about the expectations how applications respond end to end. It's more about how application is going to respond within each transaction, within each response time, how the throughputs are going to be measured at different levels of load. And usually, whenever any development cycle is going on, the whole focus is about finding the functional bugs. But most of the organizations tend to overlay the non-functional bugs under the carpet, because they don't really want to put their head on for the memory leak, the memory management bugs, the buffer overflows, etc. So the need of the performance testing is very much required, where everything is going to be on the e-retail stores for the B2B or the B2C applications. Now, when it is required as per the SDLC phases, so the performance testing is definitely required in the design phase, the development phase, and in the deployment phase. Now, most of the organization tend to practice doing the performance testing after the deployment phase. So they don't give much attention during the design phase or the development phase. And if they start to pay attention during the design phase, taking care of all the serial images they might be using from the third parties, or heavy loads for any jQuery or JS written on the front end of the application. If these things are going to be taken care of during the design phase, you are going to have a lot of easy, smooth sailing during the design process, including the development phase, where individual page and their processes needs to be identified. Because, for example, if any application is taking 15 seconds end to end, you need to identify which one of the module or which one of the page is taking the more time, and you need to break out those points by breaking them in smaller chunks to identify which area is completely taking more time than the usual, and what could be the unnecessary bottlenecks at that particular page. And then the deployment phase, in the deployment phase, you need to identify the minimum hardware and software requirement for your applications for the performance testing. Now, when we talk about performance testing, most of the organizations, most of the testers are tend to get confused, what they should be testing. So, for example, if you have a functional testing to go, you have a clear understanding of your requirement document, you have your scope of work available, and you have the right set of test cases. But when it comes to performance testing, there is no scope of work defined, because nobody think about it. Nobody has paid attention towards what area they should be covering for the performance testing, what the module should be part of their performance test plan. So you need to identify your high transaction frequency transactions. So for example, like, you need to know which of the transactions in the whole application takes more time, are being used more, are being visited more frequently by the users, because the most frequently used transactions have the potential to impact the performance of the overall applications. The other transactions, and it can also make other transactions, if they are not efficient, unnecessary, because if the login page is working fine and you are able to log in successfully, but your search for the product is not working perfectly, or taking more time than it requires, then definitely you are in a limbo of not having a good performance, with the higher frequency transactions. The second part is the mission critical transaction. So every B2B, B2C transaction are mainly laid upon from your product search to the product detail page, the PDP page, and then the smooth checkout with checkout process completely. So these are tend to be the mission critical transactions. The complete end-to-end flow that has to be working at all cost. So the most important transaction that facilitates the core objectives of the system should be included as failure under load. These transactions has by definition the greatest impact. If your application is doing very fine, your home page is not consuming much of the time, your response time is perfectly good, but your checkout page is taking the whole lot of a time, then that is where you are going to be in the soup, because you're not going to get over have an end-to-end good performance of the application, or having the desired throughput or the response time. The third thing is the read transactions. So when we talk about the read transactions, usually read transactions are the product detail page or the search page, where at least read-only transactions should be included, so that the performance of such transactions can be differentiated from the other more complex transactions. There are many small web service calls, small transactions that needs to be triggered within your whole end-to-end process. Those processes may not be taking more time. For example, the loading of an image or loading of an image from cache. So you need to identify what are your read transactions, and then you can differentiate those transactions from your high frequency and mission critical transactions. The last one is the update transactions. So on update transactions, one should include the differentiations of the performance for other transactions, because sometimes the update transaction is going to get into the complete end process, where it may take, for example, just the update of a product in the add to cart. While doing the add to cart, it may take more time than unnecessary doing the add to cart from your cache. So you need to identify all these four important factors before doing your testing. Now the performance testing process. So the whole is software testing life cycle. There is a performance testing process where like many testers need to it usually tends to jump up on the scenario creation and then running the scenario directly, ending up at monitoring and analyzing test results, but they don't care about the step 1 and 2, which is planning the test properly, identifying your right objectives, and knowing your objectives very well, and then identifying the right scenarios and creating the virtual user scripts as per those scenarios, because those scripts has to be realistic. They don't tend to be idealistic. You have got to mimic the practical scenarios, the real scenarios which end users are going to be mimicking on your application. So with these 6 steps are very important to have the complete testing process for your performance testing. That includes planning the test properly, creating virtual user scripts, creating scenarios, running those scenarios to confirm that these scenarios are running pretty fine as per the test, and then monitoring those scenarios, having the right throughput and response time, while you're executing those scenarios for your performance testing, and analyzing the test results very explicitly, because you need to take your eye over all the parameters whichever you're using for your performance results. Let it be the throughput, let it be the response time, let it be the deviation from the home page to the last page, or the image duplication point. So the main part of planning is identifying the hardware environment and benchmarking your application. So the benchmarking is about, okay, I want to run my application with 200 users, so I should know, like, I'm benchmarking on 200 users, and my whole parameter of analyzing my report should be based on those 200 users, and and identifying the percentage of each user per task, because all users out of those 200 users should be performing different tasks altogether. 200 of them should not be doing the same task as in your user scenarios. Recording the scripts as per your defined load test, identifying the right scenarios, multiple activities that needs to be part of it. For example, out of 100, from those 200 users, you can have like 50 users are doing a guest checkout, 100 of them are the registered users doing the checkout, and 50 of them are just browsing through the different product, doing the searching and browsing and going through the product detail pages. So record your scenarios in the right contents, having the right proportion, having the right set of users with more realistic scenarios, and then modifying your scripts as per your requirement. Like, you simulate your load test. So to simulate your load test, you need to identify the right parameters, the right data, your times, your environment, and then the user activities that occur during the load test with realistic think time, because think time played an important role whenever you are running the test scenarios for the performance testing. Calculations of the virtual users, that is the most uh, tricky part of it whenever you are doing a performance testing. So for example, your goal is to have 20 seconds the max response time. Anything going beyond 20 seconds is supposedly going to make your test fail, and you have a maximum of 200 users. Those 200 users should have a think time of 5 seconds. So for example, the transaction between one user to the other or one action to the other should be 5 seconds, not more or not less than that. And then users are going to be incremented within the 5 second time, 5 users per second or 5 users per 5 second. So these kind of virtual user calculation needs to be really important, and you have to be spot on with these calculation. Anything missing out from these calculations, for example, defining a less think time for mission critical scenarios or defining a higher think time for the frequently used scenarios, may end up in incorrect results, and you may not be able to achieve your objective as your test goals. So within the test scripts, it's usually the best practices is like, having a one user going end to end for one scenario. And then, of course, using different testing tools, you can use data pool and provide multiple test users with all the valid or invalid credentials. And then analyzing your test results, the most important point. Analyzing your test results, like these days, there are like multiple tools like the New Relic, where you can actually identify the peak time, having the right time when you were running the test, record those times of your test execution, and identify the rate per transaction, identifying the right throughput per second per minute within the right RPM or the desired RPM, because whenever you are, doing your calculations for the think time against which is directly proportional to your virtual users, is going to get you the right request per minute time. Let's say that one user is going to have one request per minute, then 5 users is going to have 5 requests per minute, and 25 requests per minute by 5 users if the think time is 5 seconds. So this kind of calculations need to be spot on, because when you have done your calculations on the paper, you need to make sure that you are getting the right response time on your monitoring while you are monitoring the scenarios, and then analyzing the results as per your throughput and your response time things. So there are like, every testing tool has your own own set of reports with different parameters, but majorly the parameters are global with respect to the response time, throughput, and the standard deviation which get calculated automatically by most of the performance testing tool. And you can and you need to identify the graphs available in those in the reports of those tools, how the graphs are treating and deviating from one way to the other on different pages, on different images, on different set of test cases which has been recorded for the test scenarios. Now we'll just talk about the load test configuration for a web system. So whenever we are testing a web system, so the major modules of test system are the web application is going to be accessed via internet. And this is the more of like, standard architecture where there are web servers which are connected to the application server. Application server is connected to the database. On top of the web server, there is a load balancer which is going to identify the the status of the web server and going to pass a request accordingly as per the availability of the web server. the load balancer is further covered by the firewall, which is protecting your web servers from the internet, from the DOS attacks, etc. So if I'm going to put in all the load testing tool, either IBM Rational Performance Tester, HP Load Runner, NeoLoad, MicroFocus, you name it, every load testing tool has a load generator. From there, they usually generate their virtual users or the agents they call in the IBM Rational Performance Tester. So if you're going to put your load uh, generator against the firewall, your firewall is going to block all those users usually, because it will be considered as a DDoS attack or the spam attack from the agent, because all the load will be coming up from one IP. For example, like 100 users in 15 minutes, or 100 users are going to log into the system in 15 minutes from the same IP address, is definitely going to be blocked by your firewall. So your load generator should be directly connected to your load balancer. You can do it in your best architecture, in best network architecture practices. You can have your F5, or you can have your IP whitelisted, so the load generator IP is whitelisted at your load balancer end, and the direct communication is always enabled to get through the load from this particular IP towards web servers, and then that can be further directed towards the application server. So this kind of architecture, understanding the network architecture, the network feasibility as per your requirement, which tends to differ from project to project, from product to product, and from geographical location as well. It really needs to be considered before pursuing any kind of performance test activity. Uh, One more thing is, like, this for the performance testing activity, I recommend personally for all kind of performance testing, let it be the load testing, stress testing, or simply the performance testing, these parameters need to be followed religiously, because identifying the objective plays an ultimate role for any performance testing activity. Because if you have managed to maintain good response time for the benchmarking of applications, that means like you have attained your objective. And the calculation of ramp up time and think time, as I mentioned earlier, because the behavior of virtual users are directly proportional to the think time and the ramp up time. Realistic calculations can only get the desired results. Unrealistic calculations are not going to help you with anything. It may fancy you to have a colorful report, but you may not be getting the desired results. You may not be able to benchmark and objectify your application in different circumstances, in different scenarios, in different geographical locations, or in different time zone, or in different peak hours as well. The realistic scenarios, because see, when we usually do the performance test, what we do is like we put 100 users are going to log into the system, search some XYZ product, checking out from the system. I bet, like, in the real time, not all the 100 users are going to do the same. So you need to make sure that activity schedule should have test cases based on multiple real-time scenarios, like browsing products, checking out, or continuously adding the product to cart as guest user, or it might be as the registered user. So you need to make sure you are mimicking the right scenarios. You are accessing the application as a guest user or a registered user, doing multiple activities, and making sure, like, mimicking the right behavior as an end user altogether. Server monitoring during execution, definitely that's the ultimate thing. You need to keep monitoring your server all the time whenever during the execution of the performance test, which is a repetitive, tireless activity, and you got to burn a lot of oil to do this, because it's a very steady, constant activity, and you have to just wait and be patient to monitor your server, because you don't know any time a spike will turn up, and you may miss out that particular moment or particular time or particular action of your test scenario where the spike generated was higher than the rest. And so what I have experienced personally, so whenever any testing activity is assigned, it usually goes to the performance tester or performance engineer, uh, which is a very wrong thing to do, because as a performance engineer, you are going to take up the things at particular level with your certain strength and capabilities, but you need to have a right dedicated performance team, which has to be made up of a specialist performance engineer and developer and a VAS specialist, web server admins, the server admin, and a developer who can take care of reading logs and interpreting exceptions or the hung thread, and a VAS admin who can actually go up and check the hung threads and the server logs all together during the execution cycle, or after the execution or after the execution of X number of users. So in role server, we have done quite number of times performance testing for our different clients, as a whole software development project, and as well as a more of a performance testing project. So we have done the performance testing activity for this one of the famous logistic company called Archway, where they have the problem, they have to identify the subject application because their application architecture was supposedly to be taken care to be request and used by 4,000 concurrent users, and they were expecting a performance time between 0 to 5 seconds. However, the major performance time was between 0 to 72 seconds, which is way higher than their expectations. So we need to actually make sure like how to tune their servers and how to identify using the right scenarios to help them attaining the right expected response time. The major challenges was with this uh, activity for Archway was the distribution of the load using the private cloud and architectural scaling up based on performance test results. So we were actually first running the test, identifying the results and analyzing the reports, and then we're doing the architectural level changing, but was making sure like we are distributing the load from different locations, like it's mentioned in the slide as well. Like we were distributing load from Chicago ORD, and then the tool which we were using was it Rational Performance Tester version 8.5 that time. So we successfully managed to complete this result and attaining the objective of having making sure like giving a buffer of 1,000 users from like 4,000 concurrent users. We make sure like this application architecture is able to take care of 5,000 concurrent users, and that's where we benchmark it for them that their application is not going to break for 5,000 virtual users, for 5,000 concurrent users. We actually successfully tested, using the different geographical locations from Dallas and North Virginia, and then we were making sure like 24 hours distribution from different locations, so in different times. No HTTP error was found during those executions, and environment performed very well under the data overload scenario because we actually work hard on the SLA for each page, for identification of each page by marking their network bandwidth, but not marking the overall page content and the images or the JS or the jQueries which we were using in those things. This is another case study for the B2C performance side. So where the client was on the AWS cloud, and they actually wanted to have fixed functional issues, but with the B2C side based on Aurora stores, they were having an extended model. So our approach was that we provide we actually fix your functional gaps first for the B2C side, and we provide them 24/7 support, and we monitored their application by providing 24/7 support. We made sure that we are monitoring their application using Nagios and New Relic, and from there we move forward with different with 5-week release plan where we assessed, identified, implement, and then provide the results to them. So the results were again quite successful for them. There was a significant reduction in their cost and effort for their performance testing activities overall, because we identified their peak time, we identified the number of users, the behavior of the users using the analytics and New Relic, like which are the certain areas, which are the mission critical scenarios for them, and how do we prioritize those cases. In recent past, we have been working for the circuitcity.com, and that's where like it was a complete WCS implementation. And the bottleneck which we achieved on the WCS was like, because in this application there were quite a number of third-party content were using the CDN and the data content management. And it was all on the IBM COC, so the cloud was particular in place over there. So we started the performance activity using Rational Performance Tester on premise. So and we got some really good results from not more than 5 seconds with 500 users. But since the tool was placed in our Royal Server infrastructure, and that was on premise, so whenever we were going beyond 500 users, the results were really deteriorating, and we were not getting the right results. The response time was way higher. That was reaching around 25 6. The homepage itself was taking some minutes, around 4 to 5 minutes, which was really high as per the need of any B2C site. And so what we identified is like there was a network blockage from our end, since our infrastructure bandwidth was limited with 2 gig approximate, and whenever we were going beyond 500 users, we were getting more of HTTP errors, timeouts. The server response was not available because uh, the network capability was not capable enough, was not efficient enough to go beyond 500 users and directly hit the web servers. So that's where we decided to move to the cloud. So we chose BlazeMeter to move towards the cloud. Reason being was like easily access to with the BlazeMeter cloud. So the only thing we had to do was get the IP whitelisted from BlazeMeter from different geographical locations. So without it doing any infrastructure changes at our end for the performance testing tool, we didn't have to buy or place any new hardware boxes for the performance testing tool. We just need to move toward the cloud. That's it. So we managed to achieve, the very good results, by getting the 5 6 desired response time from the overall application with the realistic scenarios, taking care of our benchmark solution, identifying the right use cases, mimicking the right kind of user behavior in it, and from there, calculations of the throughput per request, user per request against each transaction. So which was like we had with the scenarios we identified, we had the target of getting 60K requests per minute. So we successfully got to achieve that 50K requests per minute with users, with the desired users, which was and we benchmarked the application for the Circuit City with 200 users altogether. Another successful performance testing activity which we have done earlier this year is with the Singer, which is pretty much live and ready to use right now. So that's where it was a headless implementation where WCS was available, site was hosted on the Magento, AWS hosting, Aqua integration, JD Edwards, a lot of third-party integration, and then there was whole PayPal, Authorize.net, Ventive. So there were a lot of integration, a lot of third-party calls. The web service were taking a lot of DK altogether. Again, our approach was simple, we direct. So the lessons which we learned from the Circuit City, whenever we are hitting the third-party integration with the Aqua Cloud or the IBM COC, we move towards the cloud performance testing tool like the BlazeMeter, and from there we got the right results with benchmark the application with the desired 1,000 users with less than 5 seconds response time of the overall application, and the site is pretty much live and ready to use right now. They have a very strong go live event as well. Thanks everyone.